Hello students, I welcome you all. As far as this online lecture series is concerned, we are continuing the topic that is carbon and its compounds. We are going to discuss one more subtopic from this very unit, that's versatile nature of carbon. Versatile nature of carbon. Before discussing this versatile nature of carbon, let me tell you that around 5 million organic compounds are known. 5 million organic compounds are known. I told you people organic compounds are actually the carbon compounds. Around 5 million organic compounds are known. Now what is the reason behind this? Why carbon forms millions and trillions of the compounds? The reason is behind that is actually the versatile nature of the carbon. Let me tell you something regarding this versatile nature of the carbon. Before discussing this versatile nature of the carbon, let me make you people understand what actually versatile mean. Versatile mean actually embracing many subjects. Embracing many subjects. If I can simplify this term, that means having many uses and applications. First thing regarding this carbon is that carbon forms millions and trillions of the compounds. Now the question arises, why only carbon forms millions and trillions of the compounds? It's because of the versatile nature of the carbon. Let me tell you what actually versatile mean. Versatile mean actually embracing many subjects. That is, if I can simplify the term, that means having many uses and applications. Because of the many uses and applications of the carbon, we are seeing millions and trillions of the carbon compounds presently known. Now, carbon is having two important properties. That's why this carbon is versatile in nature. Two important properties. One is property of catenation and another is property of tetravalency. Let us discuss them one by one. What actually catenation is? It's actually these two properties, catenation and tetravalence. Because of these two properties, carbon is versatile in nature and it forms millions of carbon compounds. Millions of carbon compounds. Now what's catenation? Catenation is actually self-linking property of carbon. Self-linking property. Self-linking property. Self-linking property means to make bonds with itself. To make bonds with itself means actually it's a tendency or ability of a carbon. Tendency or ability of a carbon to join with other atoms, to join or link with other atoms through covalent bonds or by means of covalent bonds, to form long chain carbon compounds. Now, what's actually catenation? Catenation is actually self-linking property. Self-linking property means tendency or ability of a carbon to make bonds with itself. It's actually this property which enables the carbon to form millions and trillions of the compounds, and these carbons join with one another through covalent bonds. Because I told you people in the previous lecture that carbon always forms bonds by sharing of electrons, by mutual sharing of electrons, and I told you people that the bond which is formed between two carbon atoms and other atoms as well by mutual sharing of electrons, we call that particular bond as covalent bond. So carbon forms I can say millions and trillions of the compounds because of this property of catenation, because of the property of this self-linking property. It's the ability of a carbon to join with other carbon atoms through covalent bonds to form long chains, and these long chains can be like branched chains. Carbon can form branched chains as well. It can form straight chains. Means these carbons can join through branched chains, they can join through straight chain, or the fashion of joining may be sometimes rings as well, rings as well as closed, in closed fashion. First thing is the property of catenation. It's because of the property of catenation carbon forms millions and trillions of the carbon compounds, because carbon joins with other carbon atoms to form long chains, and these long chains may be straight, they may be branched, and they may be ring as well as closed, I can say as well, like this. Here's carbon, 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 carbons, like this. It's a straight chain. These carbons can join through straight chain or branched chain. I told you people they can join through branched chain as well. That's like this: 1, 2, 3, 4, 5, 6. 5, 6, like this. It's a branched chain of carbon atoms. Third is a closed chain or ring form. It's like this. So carbon joins with another carbon, like this. One more example, like this. Like this. Another example, like this. Like this. This is a branched straight chain. It's a branched chain, and this is a closed or a ring form. This is a fashion of joining. The carbon atoms can join through straight chain as well, branched chain as well, and ring form. They can make a ring form of carbon atoms as well. Now let's move forward. Now the question arises. Question here arises: why a carbon shows the property of catenation? Why carbon shows? The question arises: why carbon shows property of catenation? Why carbon shows property of catenation? As far as group 14 is concerned, group 14, also called as carbon family, the group includes as a carbon at the top of the group, carbon, silicon, then germanium, then it's tin, and then it's lead. So a 14th group of the elements, also called as the carbon family, because carbon is at the top of the group. As a carbon, this silicon, this is germanium, this is tin, and this is lead, baby. Now the question arises: why only carbon shows property of catenation as far as group 14 is concerned? Silicon shows catenation to some extent, that 7 to 8 silicon atoms can join through silicon-silicon bond to show some sort of catenation. But the moment 8 silicon atom joins, then I can say that's in accordance with the energy conservation, that it does not allow the silicon, because these silicon-silicon bonds are weak bonds. Now I told you people, this carbon, as far as 14th group is concerned, it shows the highest catenation. Now why carbon shows property of the catenation? The question arises: why only carbon shows the highest catenation as far as group 14th is concerned? Now the reason behind this is that to form ability of a carbon, it's because of ability of carbon to form strong covalent bonds. I told you people in the previous lecture that carbon forms, I can say other compounds, or I can say carbon shares forms another compounds because of the formation of the bonds, and those particular bonds are called as covalent bonds. Now the question arises, why carbon shows property of catenation? I told you people that it's ability of a carbon, because of the ability of the carbon to form strong covalent bonds, and because of this very property, carbon forms millions and trillions of compounds and forms, and I can say shows the property of catenation. Now the question arises, why carbon shows, I can say forms, rather, why carbon forms strong covalent bonds? Now the question arises, why carbon forms strong covalent bonds? The reason behind that is smaller size of the carbon. Smaller size of carbon. Near about, carbon is having size of 77 picometer. Picometer is that means its covalent radius. Because of the small size of the carbon, carbon forms strong covalent bonds, and because of the smaller size of the carbon nucleus, carbon atoms of the carbon, their nucleus, I can say their nucleus, the moment they share one electron, these nuclei held this shared pair of electrons effectively, rather very strongly, thereby forming strong covalent bonds. Thereby forming strong covalent bonds. Now the question arises, why carbon shows, I can say, property of catenation? The reason behind that is the ability of a carbon to form strong covalent bonds, because carbon forms bonds by sharing of electrons, and those bonds are actually called as covalent bonds. Now the question arises, why carbon bonds are strong in nature? It's because of the smaller size of the carbon, having size of 77 picometer covalent radius. Because the carbon nucleus, when they join with each other, when the carbon atoms form bonds with each other, the carbon atoms, when they join each other, they share one electron, because carbon always form bonds, and these bonds are covalent in nature. And the moment they share one electron, and they held this shared pair of electrons very effectively between the two nuclei. That means these two nuclei, carbon nuclei, held the shared pair of electrons very strongly, thereby forming resulting in the formation of a strong covalent bonds. Strong covalent bonds. The moment you people have to break this carbon-carbon bond, you people have to apply as much as 355 kg per mole energy. And that energy which is used to break carbon-carbon bond is called as bond dissociation energy. Bond dissociation energy. Now the question arises, what's bond dissociation energy? Bond dissociation energy is actually energy which is required, it's the energy which is required to break chemical bond, chemical or covalent bond. Now I told you people why I'm telling you that carbon-carbon bond is very strong, and because of this strong bonding between the carbon atoms, it forms millions and trillions of carbon compounds, and it shows the property of the catenation, because the shared pair of electrons is held strongly, very effectively by these carbon nucleus when they join with each other. And the moment you have to break this carbon-carbon bond, you have to apply 355 kg per mole bond dissociation energy. Then and then only we people can break this bond. And that's why it forms strong covalent bonds. Now the question arises, what is bond dissociation energy? Bond dissociation energy is actually that energy which is required to break this chemical or carbon-carbon covalent bond. As far as other elements are concerned, like silicon and silicon, it needs only 25 kg per mole energy to break this bond. That means this bond is weak bond and it gets easily broken. And like we have lead-lead bond, it needs 156 kg per mole energy to break this bond. That means it's because of the formation of the strong covalent bonds, this carbon shows the property of catenation. Now I told you people, let me recapitulate this, why carbon shows property of catenation. It's because of the ability of a carbon to form strong bonds. The moment it forms strong bonds, because of Why this carbon forms strong bonds? Because the smaller size of the carbon, having size equal to 77 picometers, the moment its size is very small, the nucleus of the carbon atoms, I can say they held this shared pair of electrons very closely or very impactfully, very strongly, resulting in the formation of a strong covalent bonds. And these strong covalent bonds are not easily broken. At the moment you people have to break the bond between the carbon-carbon atoms, you people have to apply 355 kg per mole bond dissociation energy. Then and then only we can break this bond. And this bond dissociation energy is energy required to break the chemical or the covalent bond. The moment you people have to break silicon, or the question arises, why only carbon shows property of highest catenation? Why not silicon? Why not lead? Why not, I can say, this tin and all that, germanium and all that? It's because I can say the moment they form bonds, and those bonds are actually very weak, and it needs lesser amount of energy than carbon-carbon bond to break these silicon-silicon bonds and lead-lead bonds and all that. It's because of this property of catenation, carbon forms millions and trillions of the compounds. Thank you so much, and in next lecture we will talk about tetravalency.